Hello everybody, Mr. McVeigh here. Here we're going to be plotting quadratic equations, identifying the vertex and the axis of symmetry when the equation is given to us in standard vertex form. Standard vertex form looks like this. F of x equals y equals a, some constant, times the quantity x minus h squared plus k, where h and k is the x and y coordinates of the vertex. You'll notice that there's a change in sign here. Yes, that is true. It's the way the equations are defined, and so you'll change the sign. H is always opposite and k is always what it is. Some people like to say, well, the left one lies and the right one tells the truth, but just remember that you have to change the sign of what's in the parenthesis. Also, x in this case equals h is the axis of symmetry, AOS, the axis of symmetry. It would pay to memorize that equation. Okay, let us identify the vertex and the axis of symmetry for each one of these examples. Example number one, we have quantity x plus 4 squared minus 2. So we know that the vertex is at h and k. And so it's opposite on the x, right? So this is opposite, so it's going to be negative 4 and then negative 2. That's my vertex. And my axis of symmetry is at the x location, so that's x equals negative 4. Example number 2, we see that there is no k out here, so that's like writing plus 0. Okay, so my axis, my vertex is going to be at positive 4, change the sign of what's in the parentheses, and 0. Positive 4 and 0. My axis of symmetry is at my x location, so it's going to be x equals 4. Example number 3, quantity x minus 7 squared minus 5. Here's my h, here's my k. I change the sign for my vertex on my x part of the coordinate, so it's going to be at 7, comma, and then negative 5 is my vertex. And my axis of symmetry is x equals 7. X equals 7. My last example looks a little strange here, but this can be rewritten, and this can be rewritten as minus 5 x plus 0 squared plus 2. Now you'll see that we do have an h here, and it's at 0, and we have a k that's positive 2. So my vertex is going to be at 0, comma, 2. And my axis of symmetry is at x equals 0. X equals 0. Okay, we look at these constants here. This is a positive, this is negative, this is positive, this is negative. So we know this one opens up. Opens down. This one's positive, it opens up. This one's negative, so it opens down into a U shape, and number 1 is positive, so it opens up. Okay. Now, an example of actually plotting in vertex form. Okay. First thing we need to do is we see the negative for the coefficient here, so we know that it opens down. So we know it's going to make a U in the downward direction. It's not going to hold water. The axis of symmetry is going to be at x equals negative 2. The vertex is at negative 2 and 7. The domain is all real. And what about the range? Well, let's see where our vertex is. Our vertex is at negative 2 and 7. That would be right here. And we know it opens down, So this is negative 7. So our range is going to be y is less than or equal to 7, because it includes 7, and we know it opens down and continues on forever. But we need to pick a few points. So we know our vertex is at negative 2 and 7. We could pick a few more points and plug them in. How about negative 3 would give us 6. Negative 4 would give us 3. And I'm just plugging these numbers in and calculating my y. So if I plug the 0 in, 0 plus 2 is 2. 2 squared is 4. It's negative, so it's negative 4. And plus 7 is 3. And then let's try negative 1. Gives me negative 1 plus 2 is 1 squared is 1. It's negative 1, has a negative out front. Plus 7, negative 1 plus 7 is 6. And we can plot these points. So we have 0 and we have 3. 1, 2, 3. We have negative 1 and we have 6, about right there. We have negative 2 and 7, that's our vertex. We have negative 3 and 6, which is symmetry right here. And the last one is negative 4 and 3, which is symmetrical here, about our axis of symmetry. So we know our parabola looks like this. It continues on forever, and you can see now our range is everything y less than 7. Until next time, Mr. McVeigh.